Hi everyone, welcome back to my channel once again. So, today we are going to discuss about the topic James Chadwick's discovery of neutrons. Without any further delay, let's start today's class. So, after the discovery of protons by the Rutherford, like scientists were thinking, oh, this is the structure of atom, like protons are present inside, like at the center of the atom in the nucleus, and outside the electrons are revolving in the orbit. Correct? Now, according to this, when they are calculating the mass of an atom, what should be the mass of an atom according to that experiment? So, mass of an atom should be equals to the mass of proton plus mass of electron, right? It should have equals to that according to that scenario after the discovery of protons and electrons. But it is not. It was not the scenario. Okay. So basically, how they uh, do that experiment, it was not happening like that. All right. So mass of the atom was not equal to the mass of the proton. So for example, mass of hydrogen, hydrogen is having one number of proton and helium is having two number of protons, right? So according to this, mass of helium should be 2 and mass of hydrogen should be 1, right? So if we are keeping helium over here, so it will be equals to the 2 hydrogen atom, right? Because hydrogen proton number is 1, correct? So this is the expectation. This was their expectation. But what is the expectation versus reality? Reality was that helium atom shows more mass than 2 hydrogen atom. Okay, so all the scientists were, very surprised how this is happening. And in order to balance this, they just started adding more number of hydrogen atom in it. They added one more, three, still also it was not balanced. Then they added one more, it becomes four, now it is balanced. So one helium atom is equals to four hydrogen atom. How this is possible? So if I say the atomic number for helium, it's 2, but the mass number is 4. How this is possible? They didn't know that. So now James Chadwick in the year 1932 performed an experiment to observe this, like what is happening over here. So let's see what was the James Chadwick experiment. So here you can see he took a polonium, radioactive polonium, and he kept it inside a lead container because you now know that radiation can escape out from any other container and lead is a very safe container so that the radiation do not escape out from anywhere else, not randomly. And there is a hole at the front of the lead container, very small hole. He did that hole, a hole for the like intention for this experiment only, so that these alpha particles, the radioactive alpha particles, can escape out through that hole for this, for the purpose of the experiment only. Okay. So this is the polonium source and alpha particles were bombarded into the beryllium plate. Okay, like Rutherford bombarded the alpha particles into the gold foil plate. Here he was bombarding into the beryllium plate. Okay, and then he saw that some waves, these waves were emitted from this plate. He didn't know what kind of wave this was. So he thought that, okay, let's do some, electromagnetism test. So he do some electromagnetism test. Now these waves were not deflected. What happens if there is any, generally what happens if there is any charged particles and if you are placing it in front of some, in nearby some electromagnetic field, it will show deflection because because of the charged particles, right? But here it did not show any deflection. So he wondered that, okay, it does not show any deflection. It might be something like, electromagnetic spectrum, any kind of, that kind, light rays, something like that. Okay. So to further, just clarify this, he put a paraffin wax over here. Paraffin wax. But he saw that these waves, when they hit this paraffin wax, no, this wax ejected out the protons. Okay, and these were detected at a detector over here. He also placed a detector. Okay, now he wondered that the any kind of electromagnetic spectrum light rays do not have that much of energy and momentum that it can hit something and the proton will eject out. These do not have that much like momentum in it. So what kind of waves these are? What are these things which is having zero charge but still they have that much of momentum or the mass that like they are very heavy, so that this is the reason when they are hitting it, this paraffin wax is ejecting out the protons. Okay, what kind of things these are? So here James Chadwick discovered the new particle which is called as the neutron. And he also observed that the mass of the proton is equals to the mass of the neutron. Okay, you can see over here. And this is the reason that uh, like in the helium atom there are two number of protons, but if we are just adding up two number of neutrons to the helium atom, so there will be total mass of 4. Okay, so now this concluded the discovery of the neutron. I'm playing a very short video for your better explanation. Please do watch this video.
In order to understand the discovery of neutron, let us consider an experimental setup in which polonium is placed inside a cavity. The cavity is made up of lead material. The purpose of using lead block is that lead does not allow the radiations to pass through from all directions. A small opening is given in the lead box, and only radiations can pass through from this opening. When alpha particles strike the beryllium metal, they release one neutron with the formation of carbon. A detector was placed after the beryllium metal to detect the type of particle. The detector did not show any deflection. This leads to the conclusion that the particles are neither positively charged nor negatively charged. They are neutral. This experiment leads to the discovery of neutron.
Alright, so I hope this is clear to all of you. Everything is written over here which I have already explained to you. You can pause the video and take your notes. Okay, so this is all about the discovery of the neutrons, and now we know that an atom has three subatomic particles: electrons, protons, and neutrons. So these are the subatomic particles. So electrons is having a relative mass is very negligible. You can see the mass is so negligible. It's like 9.1 times 10 raised to power minus 31. It's very negligible mass, but basically the mass of the atom, now we know how to calculate the mass of an atom, that is equals to mass of proton plus uh, mass of, sorry, neutrons. So we can say, number of neutrons, sorry, mass, number of protons plus number of neutrons. That is going to be the mass of an atom. I hope this is clear to all of you. Okay, so that is it for this video. This was a very short topic. If you like this, Please hit the like button and subscribe to my channel. Share this video with your friends also. Okay, so take care. Have a nice day, all of you. Bye bye.